So, hi everyone, and thank you for joining my presentation. So my name is Christos Anagnostakis. I've been working for the last decade for a Fortune 500 company doing enterprise architecture. As of recently, I'm focusing on helping organizations reduce the cost and time to market through efficient usage of data streaming technologies. So today we're going to talk about costs, but not the costs that we hear most of the time. We're not going to talk about availability zones and all that. We are going to talk about the hidden costs that the wrong use of technology introduces in an organization, and we are going to see how using efficient technologies can reduce that. So let's set the context first. Let's pick up a random organization within the EU with these problems. I know that you are not very much in contact probably with the EU, but it's a very complex environment. Some of you are already smiling. So we have siloed pricing data across legacy systems, manual data reconciliation between distributor and outlet pricing. I forgot to say that I picked up a random subject, pricing. Complex EU tax calculations handled separately per country, testing bottlenecks with limited staging environments, pricing simulation delays that impact the time to market. We have, as an infrastructure, multiple databases, ETL pipelines, integration layers. For the operations, manual data synchronization, pricing updates. Product development, custom integrations for each country, very heavy stuff, as you see. For testing, expensive staging environments and lengthy simulation cycles. And a big opportunity cost, delayed pricing decisions, losing market advantage. So let's start with a dream that the business is having. You know how the business is. They want the moon most of the time. Regarding the strategic impact, real-time market responsiveness, EU regulatory compliance, peak load handling, legacy system integration. On the revenues growth part, personalized pricing at scale, market positioning optimization, dynamic inventory-based pricing, automated competitive intelligence. On the operational excellence, business user autonomy, they would like the business users to be able to do a lot of things themselves. Automated compliance, proactive monitoring, and multi-channel consistency. This is quite a requirement. So let's go and see what would be the components of a solution, first of all. So let's examine what could be a proper architecture. We would like to have a dynamic pricing engine to handle the pricing strategies, efficient data integration layer, a rule of management framework. On the business logic side, a customer segmentation engine, competitive intelligence, inventory, and demand optimization. On the technical infrastructure, we need scalable computing platform, version control and audit trail, API first design because you want to have a lot of consumers, and consistency in the multi-channel. On the analytical and monitoring features, performance analytics, we want to know when things are going wrong and how the system behaves. A to B testing framework, alert and exception management, and on the governance and control, approval workflows, multi-level approval workflows, price, floor and ceiling controls, and compliance management. So let's see some of the traditional solutions. While I was investigating, I found at least a dozen of anti-patterns. I picked 3. So toolchain nightmare, best of breed mess, many different systems, multiple vendors, integration hell, no accountability, API not talking to each other, high percentage of custom integration code. You can have the integration platform trap when you have batch first architecture finally, high total cost of ownership, operational overhead, vendor lock-in, limited scalability, poor development experience, and AI and ML integration is problematic. You can also have a third option, the cloud-first approach, over-engineered, microservices that are gone wild, debugging nightmares, and DevOps complexity is higher than the business logic complexity. So all these three options have a common characteristic. The complexity of the solution is much higher than the complexity of the problem they are solving. So this is the harsh reality that the business is getting. On the business situation, a high percentage of requirements is never implemented. There is loss of revenue due to lack of capabilities. It cannot handle peak loads, and the manual processes are still there. On the organizational impact, you have team burnout. People are very frustrated and tired. You lose institutional knowledge because people are going. A lot of opportunity costs and a competitive disadvantage. So let's talk more about the costs. So what are the costs of this approach? We have first direct technology cost. We have licensing for ETL, DBs, and analytic platforms. We have over-provisioned infrastructure, multi-vendor relationships, and premium support contracts. On the personnel and operational costs, we have large teams of specialists, external consulting support, and vendor relationship management. On the development overhead, we have long development cycles, rework and technical depth, and integration complexity. But that's not all. We have more. We have a business impact, which is the most important cost, lost revenue from delayed time to market, pricing errors, system failures, and delayed innovation and market expansion. On the risk and compliance, we also have costs, downtime and reliability issues, regulatory compliance, potential fines, security incidents, and data protection costs. And finally, when you find out that you are in a difficult situation, you have migration and exit costs. Platform migration, the vendor lock-in penalties, data extraction from proprietary systems, and business disruption during transition. So the picture is not very good. So the real costs are hidden. Does it have to be that way? Well, apparently yes, and it's because of the silver technology bullet syndrome. People are sticking to certain technologies because they feel comfortable and they do it that way. Risk aversion, we think that this is not risky, let's keep doing what we were doing. Sunk cost fallacy, if we put so much money into that situation, let's continue. Vendor influence, analysis paralysis. We will see an example of that a bit later. And Conway's law. This last one in itself deserves a couple of hours of discussion, which we don't have today, unfortunately. So let's introduce a different solution. Let's talk about Ursa, Flink, and Rising Wave. So you know Ursa, you heard it a lot of times this couple of days, is a Kafka-compatible streaming engine that writes directly to Apache, Iceberg, and Delta Lake. Flink, you know probably as well, a distributed stream processing framework for stateful computations. And Rising Wave is a streaming database with Postgres-compatible SQL interface. I use the three logos together so that we can reference it in the rest of the presentation. So let's see how these technologies can address the core architecture. But before we go there, I need to say one thing about these three technologies. They integrate seamlessly. And this is a very big deal. So let's start with a dynamic pricing engine, how they can support on that. We have an end-to-end real-time pipeline. Pulsar is collecting the data. Flink is doing the heavy lifting on the complex processing. Rising Wave provide efficient materialized views and access to this, to all this data. They all AI native architecture. They support AI. We're not going to talk about AI today. We could talk about the fundamentals, but they do. Elastic autoscaling, event-driven optimization, and sub-second price propagation. On the data integration layer, we have a seamless data flow. The data enter, we collect data from the legacy systems via the URSA collectors, and they finish in materialized views on the other side to be accessed by the different customer applications. We have a schema evolution coordination and query quality assurance pipeline. Through all the pipeline, through all the integration, we can incorporate the collection of monitoring data and create dashboards. So we know exactly what is happening. And unified data governance. So when you check the rule management framework, we can have a unified rule deployment. So the rules can circulate, can be propagated in the system and be executed and applied in a seamless manner. We can even use AI-enhanced rule intelligence, real-time rule testing, cross-platform rule consistency, dynamic rule optimization. Let's see the business logic component. So on the customer segmentation engine, we can have real-time segmentation pipeline, behavioral triggering processing, cross-platform personalization, segment evolution tracking, all that automated. On the competitive intelligence part, integrated competitive response, AI market analysis, real-time positioning, market opportunity identification, and competitive simulation. And on inventory and demand optimization, supply chain coordination, orchestrate the demand with AI, dynamic optimization loops, supply disruption response, and predictive inventory pricing. And on the technical infrastructure, we have a scalable computing platform because we have unified elastic scaling, resource optimization, we can have global deployment, and cost efficiency. On the version control and audit trail, we can obtain a complete data lineage, a unified audit trail, we can perform AI audit analysis, and cross-platform versioning and regulatory reporting automated. On the API-first design, we get a unified API layer. Rising Wave is Postgres SQL compatible. Real-time data serving, we can consume the data either using the URSA topics or the materialized views. We have an AI model endpoints, event-driven architecture, and multi-protocol support. And on the analytical and monitoring features, we have real-time pipeline analytics, AI-powered insights, cross-platform metrics, impact analysis, and optimization recommendations. And regarding the testing framework, which is extremely important for this kind of systems, we get end-to-end experimentation, AI experiment coordination, that helps a lot, real-time statistical analysis, multi-dimensional testing, unified experiment tracking. On alert exception management, pipeline-wide monitoring, AI anomaly detection, predictive alerting, root cause analysis, and automated remediation. Finally, on the governance and control, we have, on the approval workflows, we can have cross-platform approval routing, AI risk assessment, unified approval interfaces, real-time stakeholder notification, and complete audit integration. Regarding the price, floor, and ceiling controls, a pipeline-wide constraint enforcement, AI adaptive boundaries, multi-tier validation, exception coordination, and regulatory compliance. And on the compliance management, end-to-end compliance, unified compliance monitoring, assisted by AI eventually, automatic documentation, and cross-border governance. Now, let's look about the cost. So how the combination of these three technologies influence the costs that we mentioned before. Let's start about the direct technology costs. So licensing for ETL, DBs, and analytic platforms. So since we have a single unified platform that replaces several licensed products, it is very easy. It's an open source foundation that eliminates the vendor license fees. It's a predictable pricing model versus a complex licensing matrices, and no need for license audits or compliance overhead. On the over-provisioned infrastructure, we have elastic auto-scaling that adjusts resources based on actual demand, cloud-native architecture that optimizes utilization, pay-per-use compute that scales to zero during low usage, and object storage integration versus expensive database appliances. On the multi-vendor relationship, very few vendor relationships that eliminates all the coordination overhead, a unified support model, one escalation path, one SLA, no finger pointing between vendors during issues, and a consolidated billing that replaces multi-vendor invoice reconciliation. And the premium support contracts are replaced by community-driven support that reduces vendor dependency, self-healing architecture that minimizes support ticket volume, standard support included versus premium tier requirements, and built-in monitoring that enables faster issue resolution. About the personal and operational costs, instead of large teams of specialists, we have a few generalist engineers versus an army of specialists, a unified skill set, standard technology skills that are transferable between companies, self-service capabilities that enable business users to create pricing rules. On the external consulting and support cost, we have reduced implementation complexity, which minimizes the need for expensive consultants, a comprehensive documentation that reduces vendor professional services dependency, open source community that provides free expertise, and standard training materials versus custom consulting programs. Vendor relationship management, no vendor coordination held, no dedicated vendor managers that are needed, simplified contract negotiation, one agreement versus multiple, open source leverage prevents vendor price hostile situations. On the development overhead, instead of long development cycles, we have faster delivery. We have enabled rapid prototyping, real-time testing versus waiting for batch completion. Instead of rework and technical depth, we have business logic that is not in auto-generated Java code. I put this especially for some integration platforms that advocate low or no code. Version control schemas that prevent breaking changes, a unified data model that eliminates inconsistencies, and self-documenting architecture. On the integration complexity, we have basically 0 integration points. These three technologies integrate seamlessly. Focus on business logic versus integration code. Event-driven architecture handles the data flow naturally. And we have single data format versus transforming between many different data formats. On the business impact, which is actually also has been the worst, lost revenue from delayed time to market becomes a real-time competitive response. instant pricing strategy deployment versus week of development, dynamic inventory-based pricing that adjusts automatically, a peak period responsibles without system failures. So pricing errors as system failures, well, we have higher uptime reliability. Built-in data validation prevents the pricing errors. Real-time error detection versus customer complaints that reveal the issues. Self-healing architecture that automatically retries and recovers. Our delayed innovation and the market expansion lost opportunity becomes an AI native architecture that enables real-time personalization. We can ensure rapid EU market expansion, feature velocity acceleration, and API-first architecture that enables the ecosystem expansion. Risk and compliance costs. The downtime and reliability issues are gone. High uptime SLA, self-healing distributed architecture with automatic failover, low mean recovery time, elastic scaling during peak loads versus fixed infrastructure failures, regulatory compliance and potential fines. Built-in EU compliance is not difficult to do with a combination of these platforms. GDPR, tax calculations, anti-dumping rules, automated audit trails versus manually assembling reports, real-time data lineage tracking versus week of investigations, automatic regulatory reporting generated on demand. Security incidents and data protection costs. There, we have a unified security model versus securing different platforms. Zero trust architecture with encrypted data by default. Centralized identity and access management and real-time security monitor across entire pipeline. Migration and exit costs. Well, you probably don't want to migrate if you are in this situation, but if you want, so open source foundation eliminates lock-in penalties, standard technologies, cloud portable architectures deploy everywhere without vendor dependency, and investment protection versus forced migrations when the vendors change. On the data extraction from proprietary systems, these open data formats, Iceberg, Delta Lake, that ensure accessibility. Standard interfaces versus vendor-specific export procedures. Self-service data export versus dependency on vendor services. And no data export fees or artificial limitations. And what about the disruption during the transitions? Zero plan migration needed. A platform grows with business. Gradual feature enhancement versus disruptive platform replacement, continuous operation during infrastructure changes, and backwards compatibility that ensures existing functionality continues. As a conclusion, beware of the hidden costs when you choose a technology for your architecture. Seamless integration between these technologies is mandatory for your success. If consistency and reliability matter to you, remember that they are either built in from the ground up or not there at all. And last but not least, take a long look at the next slide. So the question isn't whether you can afford to use the combination of these three technologies. The question is, can you afford not to? Any questions? Yes.
Of migration took, and what challenges did you face? Because you mentioned like people like their tools, right? And many other challenges that were present in the beginning. So where are you in the process right now, and what maybe interesting challenges have you faced on the road, and how did you address them?
It depends on the context. I picked up three options, three bad options. Actually, they're three worse from the dozen that I have identified in general, because I wanted to highlight all the problems that you have, but you don't know that you're going to have. So people are very optimistic when they are picking technologies like this. You know that already. But then the bad things happen. It really depends. But the problems that I mentioned, the issues that I mentioned, take a lot of time. I would say years to address. I talked about analysis paralysis. So if you see the first example that I took about assembling off-the-shelf systems and create a mess. So you might get into a situation that you are investigating this option, and you find out that it's not a good one, it's not interesting, and then you move to the second option. Let's say pick up an integration platform and start to try to find a solution in-house without using this. So you engage all the professional services. You know the story, right? An army of people, then you make a POC, and you make an evaluation, and then you make a second evaluation. You start with 800K, for example, and you finish with 2.5 million. And then you say, no, it's too expensive. I go back to the off-the-shelf systems, and I close the loop. So this is the analysis paralysis that I mentioned. So it really depends on the path that you take, but whatever of these dozen things that you select, the path is long. In my experience from the past years, it's a few years. You're not in the months, basically.
Thank you.
Any other questions? Yes.
So on the last slide, you mentioned like one question you have to ask yourself,
Yes.
Can you afford not to have this, right?
Yes.
So is there any quantifiable number like how efficient this solution is for someone compared to a legacy solution where they may use some other system which is going to be costly? Like just some average benchmark, like this is going to be 2x cheaper, 3x cheaper. Do you have any number on that?
This is, no, I don't have really numbers. So that's also the reason that I put so much information. You see, no images, so much information on these slides. So, so that actually to give you the opportunity to have a look, to pick up what is interesting for you. Not everything is interesting for everyone on that. There are even more. So in the beginning, I was about 60 slides, but it was impossible. So I tried to go quickly. So it really depends on the case. But the basic difference of the legacy, let's say, choices and the three technologies that I mentioned is the seamless integration. So that's why I highlighted this point. It's very important to have the seamless integration and of course, all the other benefits that these technologies are bringing on the table. But the seamlessness of the integration is mandatory for the success. The other problem that you have, and we have some time, maybe we can talk about, is Conway's law that I mentioned. So if you would like to go towards that direction, you have to fight all the things that I mentioned that prevents you to go towards, a good solution. The last one was Conway's law, and what happens with Conway's law is that your organizational structure is imposing you an architecture. We have the illusion that we are choosing the architecture, but we are not. We are being imposed an architecture. This is what Conway said some time ago. So it's very difficult to get out of this. So if you, we have a few minutes, so we can talk about that maybe if you're interested. So as long as you cannot change your organizational structure to match your architecture, you will have problems. If there is a mismatch between the two, the organizational part wins, you lose. So the only way to be able to do this change is by introducing this kind of technology. You make it possible to transform your organization. So if you introduce this kind of technology, you are not in the silos anymore on the implementation side. So you have a platform that can supply data for your teams to work, which means that you can imagine a different way to organize your teams. So you go the other way around. This actually has a name. It calls inverse convoy maneuver. So you start from the ground up to modify your organizational structure so that they match again. Because remember, if they don't match, they win.
Thank you.
You're welcome. Okay.
My question is very simple. Okay, we can adopt the technology, that is correct. But the consistency and the long run, that is the first question coming from the client side when we are onboarding the technologies. The second one is how many resources are going to be available when we adopt any technology. Like you come up with these three combo to minimize the cost, and so that is, I want to understand it. Yeah.
So can you please repeat the question?
My first question is, adopting a technology means we want to maintain a long-term consistency and reliability of the product. That is first thing. The second thing is that resources available on the particular technologies, that is also be very important because we want to maintain the product for a long period, right? So that is also be these two.
Yeah. Let me start from the resources. This is something that I heard a lot in the past. So, for example, if I choose this technology, then I have resources available in the market. If I go that way, it's difficult. But here we are talking about standard things today. It's not about Kafka or Pulsar. It's about streaming, right? So today, streaming is something that quite a few people know. So there are resources for that. And competent people that understand streaming will be able to work with both, right? So your first question, I'm not sure I understood it very well. So may I ask you to repeat it again?
Any technology when we are going to be onboarding, so the client always looking for a long-term maintenance. Maintenance means, okay, the product is going to be available for these many years, and also we have a support from the product, who are the software product. And suppose if it is in open source like a Flink, okay, open source, it has a more flexible customization process. So that's the reason when we are any product, when we are selecting onboarding into the development process. So these are the first level checking, right? That is my question. Means why we want to go these three. You are only comparing of some of the problems, right? But what is the advantages? That is also be important. Means how because any success stories also be, they will consider it previously when we implemented or not. That is also be considering.
Yeah, I have a hard time to hear.
Okay, no problem. Yeah, it's not important.
Let's talk about that outside. Any other questions? Okay. Thank you very much.